And I'm going to talk to you today about application architecture and scalability. First thing I want you to know about me is that I have a wonderful wife and noisy terrier upstairs, who thankfully is also cute. So if you hear barking upstairs, he's in his crate, but this is the time he likes to get a little barky. Second thing I want you to know about me is that I am an instructor over at Tech Elevator. Tech Elevator is a 14-week programming boot camp. We teach Java and C# tracks. All students will get a full stack education, including SQL, relational database design, JavaScript, front-end JavaScript frameworks, and very project-oriented curriculum. I love it. I've been with the organization for a year now, but I've been watching the students for probably 3 years prior to that from having worked with some of our grads. And we do believe in Florida. This is just, I think the marketing department omitted it for a label they wanted to put in the lower right. So just to clear that up, because a common question I get on that graphic there. Some things about my background, because it is relevant from where I'm coming from and what I'm presenting today. I have spent about 20 years in the .NET world and JavaScript since maybe about ECMAScript ES6 maybe. But I do a lot of work with startups, people within the early stages or early middle stages of launching a software as a service application, and getting that into the hands of the users or other departments, and then kind of scaling it up as it takes off. That tends to be where I've excelled in my career, and I came to love it a lot. So just bear in mind that I'm not coming at things with the perspective of a large organization, but like somebody who's starting small. So most of the advice I'm going to be giving to you is for those smaller or mid-range organizations, but these technologies are really applicable across the board. So my goals for today are to give you a very high level, kind of a broad overview of application architecture and scalability, focusing on web applications. I'm going to be happy today if you come away with this with a greater degree of comfort talking about scalability concepts. If you learn of a thing or two that you might want to look into more, do a little bit more research, a little bit more learning. And if you come away with this with a little bit of wisdom for things that you might want to avoid, because there's some common missteps that people can have related to application scalability, etc. So this talk, I'm just going to launch right into it pretty quickly here. We're going to start with a few key course concepts that I want you to understand before we get into the bulk of the talk. The bulk of the talk is really talking about scalability and peeling away 5 different layers. We're going to start talking about web servers and application servers and scaling those. We're going to move on to talking about scaling the database layer, the data access layer. We're going to talk about some special concerns around web APIs or web services with scalability. And then we'll end really talking about front-end concerns. And finally, we'll talk about some more advanced concepts related to microservices and some of the more emergent technologies over the last 5 years or so. I'll wrap us up with just some of my final words of wisdom, my recommendations, some recommendations for books if you wanted to learn more. But I do want to stress, this is a very fast talk, very broad talk. We're covering a lot of things. So I do want you to interrupt me with questions. Bhaskar, if you could chime in with questions that come in from Twitch or Zoom, I would really appreciate it. I do get paid to be interrupted, so I'm totally happy with it. And I believe that you're going to keep your questions in mind easier if you interrupt me during the talk versus waiting for the end when I'll be asking for questions. But that said, I do understand not being willing to interrupt. It's okay. A final disclaimer, I am talking about some things that I'm not an expert on today. Anytime you're giving a talk, anytime you're writing something, you're always stretching a little bit. And there are areas I'm talking to you about that I'm very much a layperson in. So I might not be able to answer all your questions, but I'm going to give it a shot because we're all really on a learning journey together. So without further ado, let's clear up some terms here. When I'm talking about application design today, to this audience, I'm talking primarily about web applications. So anything that's going to run in your web or mobile browser, or potentially on your smart fridge, apparently. And we're looking at kind of a client that runs your code, your HTML, your JavaScript, your CSS, and it makes a call out to some sort of a web or application server that has some sort of a public-facing API. We'll talk about APIs in a second. And that server is going to typically take some action and return a result. And often it's going to need to talk to the database to get some sort of information from that database. By the way, talking about databases, today I'm primarily talking about relational databases. I will be mentioning NoSQL databases during a slide, but just for point of simplicity, if I say database and I'm not clarifying further, I probably have relational databases in mind because that's what they have tended to be for older organizations. So this is sort of our standard modern web application, sort of an architecture. But let's talk a little bit more about APIs. And as a teacher, I get a lot of students who are confused about what an API is, and I like to compare them to drive-through windows. And no, that's not me in the bat suit. I wish it were, but I'm not that cool. So I compare an API to a drive-through building. So I might drive up to a drive-through building, and it's got a little board printed outside that tells me what I can order, and I can say, hey, I'd like a box of chicken fingers, no slaw, extra sauce, and a large Coke Zero. And I'll pull around to the window and I'll take a bunch of money and I'll throw it in the window. And then that's basically the system API. And that system is either going to spit out the food I ordered, or they're going to say, sir, you didn't give me enough money, or sir, this is a dry cleaning store. You can't order chicken here. So these are the kinds of things that an API is. It's a way of interfacing with your system. It's an external access to this brick and mortar building. We don't necessarily need to know what's inside of the system, but it's an exposed way to interact with it in a safe manner. So a little bit of a comedic thing, but that helps people often get APIs if they're a little fuzzy on that concept. But let's talk about scalability. So because I like stories, and stories are a lot of fun, I'm going to be telling you a story about a fictitious startup today called Reddit. This is just like Reddit, but only oriented on burrito-related content. Now, Reddit has made a wonderful little application. They've hired a crack team of moderators to ban anybody who posts non-burrito-related content, and they're confident that if they can get to a certain size of usage, they'll somehow be able to make a profit. Not a very serious story I'm telling you here, but yeah, the talk should be fun, so let's make it fun. And so right now they're focusing on pouring everything they can into marketing to increase the amount of active usage. And they invest and invest and invest in that. And you know what? Usage starts to go up. People start using the application. So this thing that they've been building, it's starting to pay off. But now they start having performance issues for the first times in their software's career, or their software's lifetime. They're starting to get pages taking longer and longer to load. They're starting to get errors that pop in every so often. Pages will show error messages. They might not even load correctly. And the system's just not able to handle a lot of users using it at once. This is very common in software as a service organizations that start to get successful. It's a good sign. It's a little alarming, but it's a good sign. And the first thing that an organization should do is that they should install some form of application performance monitoring software on their server. Hopefully they already had it installed already, but something like New Relic or Raygun or Ozcode, there's a bunch of these little tools out there, these APM, application performance monitoring tools, that you install on your web server, and it watches the traffic come in. It takes measurements of how long it takes and where your code is spending its time. And then it will populate a nice little dashboard just like this one. And it'll give you a nice little area chart of like, hey, we're starting to get really slow response times. It looks like most of our time is being spent here in this blue zone, which if we look at this graph, this is .NET Common Language Runtime code. So this is your web server is taking a lot of time here, versus yellow might be your database, or you might have some cache stuff going on too. And you can also look typically and see what pages or what request types are the slowest. So is this a uniform kind of a thing that's all pages are slow, or is it a couple key areas? And you can usually look at something like this and you'll get an idea of what's going on. And typically the first thing you're going to want to do as an organization that starts to get some degree of success is you're going to want to pay attention to your web server. But these tools will confirm what your problem is. And so you really want to look at these, rely on these as you're making improvements, just to make sure there really are improvements. But let's say that it's Reddit's web server. And so they need to start looking at scaling their web server. There's a lot of different ways they can do that. The easiest way of doing that for a new organization is to scale their server up or scale it vertically. So they might be running on a really cheap server that doesn't cost a whole lot to purchase or to rent from a data center or some sort of a cloud computing provider like AWS, Azure, Google Cloud, something like that. And they can either go out and buy more memory if they own the server and put it in the server, or get a better server, or they can ask whoever's hosting them to move it to a better tier. This is scaling up. So now we have more memory, better processor power, larger disk space, whatever it might be. And all of a sudden, this beefier server, this bigger server, is now able to keep up with the requests. It's like flicking a switch, agreeing to pay a little bit more, and all of a sudden everything is back to normal. All your little yellow blinking lights are gone. Your customers are happy again, and you've just bought yourself time. And this is usually the right thing to do for an organization. Is as soon as you start to see these issues, and you'll want to scale up a little bit. Okay. There's some limitations to that. One of those is cost. Typically, you tend to about double your billing every time you upgrade your server. And at a certain point, that becomes a little bit unmanageable from a financial perspective. So that's one drawback of scaling vertically. Another drawback is that when you scale vertically, the application actually has to go offline and then come back up under the new server. So anybody who's trying to use it is now unable to use it at all during that time. And the same goes for if you're trying to downgrade it to a lower tier, right? So this works, but you usually try to plan around it, like do it on a weekend or an evening or something like that. The second drawback it has is that servers don't see a uniform level of traffic typically. If I'm writing a line of business application that people are working with in the workday, well, the level of usage, the requests per minute at 3 a.m. is going to be very different than the level of usage during peak hours at 3 p.m., right? But I still need to have a server that's going to be able to handle that level plus a little bit of comfort room. And that server is running all of the day. So if I'm renting that server from Azure or AWS or wherever, I'm paying for that same high-end server at 3 a.m. as well as 3 p.m. I don't necessarily need it during those times, right? So there are some inefficiencies, especially for renting a server from somebody. So because of that, once you hit a certain degree of scale, it becomes less expensive to scale horizontally. We're scaling out. With scaling out, we keep kind of smaller servers still, but we add more of them, and we add something called the load balancer. And the load balancer is some piece of hardware or software that your application is connecting directly to. And it's going to say, okay, I got a request. Now I'm going to route it to this server. Okay, I got another request. I'm going to route it to this server. And it does it kind of round robin style. It tries to spread that load out evenly. And you can add or remove servers as you want from this pool of application servers. And so this is very scalable. You pay for everything that you're adding, right? Because you either got to buy a machine or you got to tell Azure you want to spend a little bit more money that month. But it lets you scale a little bit more dynamically. And we call this elasticity. So with elasticity, I do apologize for this graph. I have two legends going on. This one on the right is the number of servers, and that corresponds to the orange bars. And the blue is the number of requests per minute, like we saw before. But with the elasticity, we can say, hey, most of the time we only need one server going on. But we know that as soon as 8 a.m. rolls around, we're going to need a little bit more. So let's schedule it so we automatically start another server up right before 8. And maybe we have some dynamic rules that say, hey, if our servers appear to be really busy for more than 10 minutes, then add another server to the pool up to a limit of, say, 5. And if they seem to be a little underutilized, well, okay, let's start scaling it back. And so this sort of elasticity really lets you get the servers you need at the times you need them and only pay for what you're actually using. So this is one of those huge advantages that we get from cloud computing in particular, because you can just click a button and set up these schedules or set up these automatic rules, or you can click a button and manually scale it if you want to do that. But that's really a good way of solving that server scalability issue in the long term. So Reddit has done this. They're doing well. The burritos are flowing. People are happy. But then they continue to grow. And now they start to have issues again. And they look in their application performance monitoring tool, and it tells them that it's not the server's problem. It's not the server that's going wrong now. Now it's a database. And it's because of something I didn't show you in the last slide. It's because although we're getting all these requests in a given second, and they're getting spread out evenly to our application servers, all of those are still talking to the same database server. And each one of these requests might make 5 queries against the same database server. And so while we can scale our application servers dynamically, they're all still hitting that same database server. So at a certain point, our database server is going to get overwhelmed, and it's going to start to encounter performance issues, right? Now, the first solution to this is a fairly obvious one. It's the one that we use for the server side. We scale up. We move from a low-end database server to a one with a better processor or better memory or better disks. So usually you'll move from something from cheaper hard drives to a solid state drive or a premium solid state drive. So it's really quick to read and write. The downside of this is that this becomes really expensive because if you have a lot of users using your application, they have a lot of data likely, right? And so you need a big hard drive. And if you're getting a big premium, 1 terabyte SSD, well, that's a lot of money per month. And so doubling your database server eventually, you can't do it anymore, right? Like you can't afford it. Your business model just doesn't support it. And so you start to have to augment scaling up your database with some other measures. And typically, once you start having database performance issues, you are now in the territory where you're optimizing your queries, your SQL queries, throughout the rest of the lifetime of your application. So you're devoting some development time every sprint or every month or whatever you're using for scheduling. So some degree of development time is going towards looking at your queries, optimizing things, proactively looking at what's going slow and what you can do to improve it, right? And so you're spending all your time, well, not all your time, you're spending some of your time just taking care of your database, probably hiring a database engineer or database administrator, somebody like that, to start really caring about these things. Usually startups don't need a DBA. Well, in retrospect, they often should have had a DBA, but usually they can't afford one at a small scale. But you have to care about query optimization. You may be asking yourself, if we can scale up, then why don't we just scale out instead? Well, the problem with that is that if we just give each application server a different database server, there's no guarantee that my request is going to go to the same server that I stored the data on when I go to edit it or to read it, right? So if I'm posting a new burrito I found at Chipotle, it might get stored on database server 1, but when I go in there to add a comment to it, it'd look for it in database server 3, and it's not going to find it. So this doesn't work. Scaling this way doesn't work. Instead, the way we scale horizontally at a database level is a lot more involved. It involves something called partitioning or sharding. And with a partitioning model, we take a really big database and we say, okay, we need to reduce the size of this database. What if we could chop this database into X smaller databases, where some of our customers are using this database and some of our customers are using this database and some of them are using this one, and they're always using that one based on which customer they are. And so you start to say, okay, what are the unique partitions we can do in our database? And it's different based on your business model. It might be customers if you're looking at something that people don't share their data between other accounts, like in a multi-tenant model. Or in the case of Reddit, it might be you have one server for comments, you have one server for images, you have one server for likes or something else, right? There are a lot of different ways you can partition databases, but they're usually a big project. However, this tends to be a really good way of getting a relational database to scale horizontally over time. It is a big project that your team has to worry about, and you have to plan for it for a while, unless you're using a database that might support it out of the box. Some of them do nowadays, and on the premium side, so that's nice. But let's talk about NoSQL databases. These databases are sort of designed to solve this horizontal scalability issue. So NoSQL databases, I do hate the name because sometimes there's actually SQL involved, like Couchbase has that, I know. But these are non-relational databases. So these are 4 different flavors of databases that store their data differently than a relational database. So you have a key value thing, which is kind of like a JavaScript map or a dictionary in .NET if you're familiar with those. You get your document databases, which are somewhat similar to a key value database, but they usually have a little bit more querying capabilities built in. You get column oriented, which is sort of like a tagging kind of a model where everything's in a table, but you can add whatever columns you want per given row. All of these things, you throw away some features that relational databases have. You don't have the schema enforcement, at least the same way that we're used to, right? So there's nothing telling me that this has to be an integer or it has to follow the following format to even get in my database. There's nothing saying, hey, this relationship has to exist, or when I delete this, it doesn't do that. No, there's an asterisk next to that because I'm not a NoSQL expert. Some of these databases may have some of these features by now, but in general, this is true. Finally, we have a graph database, which is really more of like a social network kind of a thing. So you're going to have nodes and edges. So imagine LinkedIn, right? I'm going to be a node in LinkedIn. I'm a person on there, and I've got all these edges. So I might follow Basker. He might not follow me back. Actually, we're connected, but I digress. You have these relationships between your little elements, and each one is going to have data, like when I started following that person, or when we connected, or where we worked with before, potentially, something like that. But the advantage of graph databases is you can query them and say, hey, for people who know Basker, who else might I might be able to suggest to them that they might reach out to and include in their network. So each one of these four has their own unique purposes and unique situations, but they handle scalability differently than relational databases, and all of them tend to have some degree of partitioning built in. So this isn't a problem you tend to worry about with NoSQL databases. You need to worry about other things with them, but this is a good way to handle scalability long term if you don't want to go the partitioning route with a relational database. I'm going to pause the drink and wait for questions to come in. And again, please put them in chat if you want them asked. I'm more than happy to have interruptions coming my way. But let's talk a little bit about APIs. Because APIs, although they're handled by the server, right? Like when we handle server scalability, it handles API scalability because the API is a part of a server. There's some special concerns that we need to think about, because when you don't do an API well, you're adding a lot more stress to a system. There's a lot higher of a need to pay attention to scalability when you're in that kind of a mode. But the first thing I would recommend is that once your application starts to get users and regular usage, you need to look at adding rate limiting to the picture. Rate limiting is a way of saying, hey, this user or this IP address or this authentication token can only make a request once, let's say X times in every Y seconds. So maybe we can say we only can make a request 5 times in 1 second. That might be a healthy thing to do, or 100 times in 60 seconds, or whatever your limit is going to be. And your client application is going to make requests out to that API, and it's going to say, okay, I know who you are. That's fine. That's fine. That's fine. Oh, you made too many requests to me. I'm going to give you back a 429 status code. I'm going to tell you made too many requests, and I'm going to tell you when you can next make a request. There's usually a whole lot of headers involved in this. You can look it up if you're curious. But this prevents any one user from abusing the system intentionally or otherwise. The first organization that I was a part of that really bumped into this need was not expecting to bump into this need. And they had an enterprising user decide to build an auto refresh browser plugin. And they had this thing sitting on a nice little dashboard that showed us all sorts of information about all the work entities in their system. And they wrote this plugin and said, hey, it'd be great if I can just run this, and it's just going to auto refresh, and we'll be able to walk by and see the current status of everything. This is great. I love it. Except they didn't implement right. They used JavaScript's set interval function, but they forgot to include the interval for which the method would call. And the way that acted in JavaScript was it actually told the browser to make the call as frequently as possible. And so probably 50 times a second, it's making a request out to our servers, making API calls out to our servers to refresh the page, and it's hitting the most expensive page in our application because there's a lot of stuff going on in dashboards. And none of that was cached. We'll talk about caching next. And every time it says, oh, this is a valid user, they're authenticated, they're authorized to do this, cool, here's your data. Well, you got all these requests going on, and it just brought down the database. It brought down everything. And so that user couldn't get anything. And anybody talking to the same pool of servers couldn't get anything either. And so this one user tried to implement a feature on their own, and they wound up bringing everything down for all of our users until we were able to figure out which IP address it was and temporarily block it. So horror stories from startups, but you need rate limiting sooner than you think you do is the moral of my story there. So let's talk about caching. So let's look at Reddit, right? So imagine we have a homepage and it's got like the top 10 most popular burritos today. And Julie makes a call out to the application server, says, hey, I'd like the list of top 10 burritos, please. The application server says, great. I'm going to check my cache to see if I have a known list of burritos that's valid. Oh, I don't. Okay, well, I'm going to make a call to the database server. I'll query it. I'll take it back and I'll give it back to Julie. In the meantime, I'm going to stick it in my cache and say, okay, list of top 10 burritos. This is good for the next 10 minutes. Okay, cool. Well, now Bill comes and he says, okay, I want to see the homepage too. So he makes the same call and it checks the cache. It says, hey, do you have the list of the top 10 burritos? Oh, I do. Yeah, and it's still valid. And so it spits it directly back out. It doesn't talk to the database server at all. And the application server doesn't need to wait for it to finish talking to the database server. So it eases up the load on the database server, and it also frees up the application server a lot more frequently. So if you can figure out the most frequently requested things and cache them, you can usually save a whole lot of load off of your database server and your application server. It just makes everything faster. So that's pretty cool. Another anti-pattern to warn you about: when we are building a feature to say like notifications, show me my notifications in an application, it's very tempting to have a simple polling model where we have our JavaScript application making a call out to the server saying like, hey, does anybody like the picture of the nice burrito I posted? Nope. Okay, fine. Well, I'll wait 15 seconds and I'm going to ask again because I want this little bell in the upper right to light up. Show me a nice little notification. And so you keep making these same requests, and then somebody eventually does like your picture, and now you make your call, you get the thing back that says, hey, yeah, it did. Cool. And it works. And this works fine for low usage systems. But the problem is people leave their browsers open. And they'll leave their browser open and go out to lunch or go to a meeting or even leave work for the day, and their browser's still there and it's still making a request every 15 seconds or whatever it might be. If you got 100 users, well, and you're doing 15 requests a second, or 15 requests every 15 seconds rather, so that's 400 requests in a given minute, right? So this is a problem that scales up based on your usage levels. And I've actually seen these graphs, these performance graphs of how many requests we're getting per minute and the constant low level of drain on the server. So you want to avoid this if you can once you start getting usage. A better way of doing this is by using WebSockets or push notifications, where the client will say like, hey, I'm going to connect to the server. Let's open a connection. Okay, I'm not going to talk to you again. I'm going to use WebSockets here. You know who I am. If you get a notification that looks like it's for me, send it to me, but I'm not going to tell you anything. Just know I'm here, know how to talk to me. And then when I go away, it might close the connection, or the connection might time out. This is a much better solution for your application for scalability purposes. It's a little bit more involved technically, but users actually get the notification sooner and your server is less taxed. So go to a WebSockets type of solution when you can, would be my advice there. So when we're making web services, we often are tempted to make these really small, concise methods that have a single responsibility, right? They're doing one specific thing that makes it really flexible so anybody can use our API. And now our client is going to say, okay, I'm going to make some calls. I'm going to get some things. I'm going to make some subsequent calls based on the thing I just got. And they're making all these little calls. And it gets a little chatty, as we might say. The problem with these things is that each one of these things, we have to serialize our message to the server. The server has to deserialize it. That message may fail, so we need to write error handling logic for each one of these calls. Each one of these, we have to wait for the network. If we're far away from the server, it might take a long time, right? So this is a very good approach for making small methods in code. This is a very bad approach for building an API because you pay for the penalties of an API all the time in this model. A better model might be to offer some specialized methods where we say, okay, I'm building this specific method for my application. I just want to get the details of my project. Give me everything related to all these things. So instead of making 4 calls, I'm making 1. It might take longer, but I only have to do my error handling in one place. I only have to pay for serialization and deserialization in one place. and it ultimately makes your application simpler, easier to maintain, and faster. Now you can still have those little methods for things that need them, but having these really specialized methods is often very, very good. Related to this is the idea of GraphQL. GraphQL is not one of those technologies that I've been able to play with yet in my career, but I have been watching it with keen interest. GraphQL is essentially the ability to send a query to an API and says, like, look, I want to get this specific user. And attached to that user, I only care about their name property and what projects they're on. And on those projects, I only care about the name of the project, the ID, and the tasks. And you can be very prescriptive about the exact results you want the server to give you back. And this lets you get more data back in a single call. It's a very efficient way of doing things. And if the client ever needs anything more that they weren't asking for before, they can add the new property here. Like they make a very similar call. You don't have to change the server at all. You don't have to deploy anything. You're just tweaking your JavaScript a little bit, and it's doing something a little bit differently. So GraphQL is definitely something I would look into if you're looking at a lot of like related entities. Other things I've seen that can improve performance, if you happen to be working with a service that works with large sets of data and you're still using XML to serialize everything, move to JSON. It can actually make a huge difference. Additionally, it may be worth looking into gRPC, which is sort of a protobuf type of solution. I've not worked with this technology either, but it's very interesting. gRPC lets you basically open up streams of data and stream things in binary fashion. It offers a lot of versioning support and compatibility, and it's also very, very fast. It might not be the best thing for a public-facing API, but if you're looking at two services that you control, this can often make things very, very fast. So some things to keep in mind there on the API side. I'll pause a minute for Diet Dr. Pepper. But we'll say that Reddit continues to grow. Somehow they decided to turn burritos as a service into a business concept, and they're doing pretty well. Users in the States are really, really happy. Users overseas are really, really sad. They say the application is still slow despite all the work we've done. Well, why might that be? Well, usually the reason for that is due to latency or lag. So if we're hosting our server out in the west side of the United States, users nearby might have a pretty good experience. But users in the UK or Europe or India or China or Australia, they have to wait for their requests to go all the way, across the oceans and over to the data center and then back to them. So this is adding artificial delay to every request. So every time they're navigating, every time they're making a request out to an API, they have to wait for it. And it's making for a poor user experience, even though our application servers are running really, really well. There's a few things we can do to try to improve this. First thing we often do is we will minify our JavaScript and our CSS. Minification is the process of taking something built for a developer that might have comments and line spaces and tabs or spaces, and variable names that might make sense to you, and it transforms it automatically into something that's as concise as it can possibly be while still having the same behavior. This is usually something that's done by your build tool. In modern JavaScript development, that's usually Webpack, but doesn't have to be. And the developers are still able to work with the same JavaScript or CSS that they were working with before. The difference is that these output files are much smaller, which means that they take less. They can be sent across the network faster, right? So that improves our user experience for the end users quite a bit. Related to this is the idea of bundling, of splitting large JavaScript files into smaller JavaScript files, and only including the bundles that you need to render a given page or a given area of your application. And when you enter a new area of the application, it might download another bundle. So if I'm going to Reddit's homepage, for example, it might download everything it needs for that page, but as soon as I go into a post, it's downloading logic related to the post. If I click on a user profile, it's downloading JavaScript related to the profile management, things like that. And this is another thing that all of our major single page application frameworks and JavaScript can handle. Typically as part of Webpack, but they all have answers for it. Another major thing that we look at on the client side is we look at content delivery networks, or CDN. CDNs are services that another company provides that exist throughout the world, and they basically take your web application content and they cache it. So when your users request it, it actually finds it in your local web server, and it doesn't need to go all the way back to the States and find it. When you make a new change, like you update your CSS, it's going to slowly propagate its way to the other servers. So your users overseas might not see the changes as quickly, but they will see them typically within 7 days. And there's often ways you can clear the cache in the CDN to get it quicker. But this results in a lot quicker of an experience for your end users because they spend less time downloading your files, which is pretty cool. Another thing kind of very specific to the JavaScript world is we have this idea of a service worker in our progressive web applications. That's a whole other talk to really talk about what a PWA is and what a service worker is and how you work with them. But the short version of a service worker is it's some sort of a JavaScript process that's going to run on your machine, and it's going to intercept requests that your application makes and responses that come back. And what you can do with the service worker is, well, you can do a lot of things, but one of the big things you can do is you can cache it. So we can remember the last HTML and CSS and JavaScript for the application. So when we start up our application, we're grabbing it from the local cache that's stored on your machine. So even if I don't have an internet connection, I might be able to pull open Reddit and look at the latest content from the last time I was around. And in the background, the service worker is trying to talk to the server. And once it gets the data, it'll update its internal cache. And I can be posting pictures or comments or whatever. And if I don't have an internet connection, the service worker can be configured to store them in your cache. And then when you finally do have that reliable internet connection, it can spit them back out to the server and try to reconcile it on the server side. So service workers are complex, but if you're in an area that doesn't have reliable internet connection, if you're traveling a lot, your users are traveling, this can really be worth it and helpful. And all of our major JavaScript frameworks support this to some degree or another. So pretty cool stuff. I am certainly not an expert on it, but something to look into more if that's up your alley. So let's talk about some other advanced concepts. I'm going to loop around a little bit and go back to talking about databases for a second. One of the reasons that databases are slow, relational databases here, are that when we're making updates on the database, we typically will lock a given row or maybe even a table or a page of data on a table. And while we're updating that, nothing else can read it or update it or write it. So if you have a database that's writing to things a lot, even if your database server is really, really high end, it can still be very slow, even if you're using like the proper indexes and everything. So this is sort of a weakness of relational databases. Of systems that are frequently updated, involve frequent writes or update operations. And a newer technology or newer discipline coming around is this thing called event sourcing. And event sourcing says, well, if updates are so bad, why do we bother with updates at all? Why can't we just store events in our database? An event might be something like, I created a post, or I edited my post, or I commented on a post. And so you can have a whole bunch of events related to the same entity. The database stores them in sequence. It says, okay, well, here's the creation of this entity. Here's this edit. Here's this edit. And when we're querying, we can say, hey, give me every event in order for entity 42. And now it pulls it out. It kind of rehydrates it is what they call it. And you can kind of fast forward it a little bit and say, okay, if we created it like this, and then we've edited these fields and these fields, well, our current value should look something like this. So you're going to have a lot of records in your database, a lot of rows in your database, but you're not having to deal with updates anymore. You're just doing inserts into your database. So that's really fast and avoids some of those locking concerns that we had before. So that's event sourcing. Another database technology to be aware of is something called read replicas. With read replication, we have our database and we have a replica of it. And this is a read-only version of that database. And the database technology in question is synchronizing it automatically. So every few seconds or whatever, it's going to push over the latest updates it has. So this read replica is going to be pretty close to the current values in the database. It's not going to be exact, but it's going to be pretty close. And if you have an application that doesn't need exact values, well, you can just read from it. You can't write anything to it because that's handled automatically, but you can take some of your load off of your primary database and not having to worry about those locking scenarios anymore, and just read from your read replica. You take these two concepts and you combine them together, and you're looking at something with a wonderful name that I hate, but it's a very appropriate name for it. It's the CQRS, or Command Query Responsibility Segregation. And that's really a mouthful. But what it's saying is, I'm going to split my logic in half. So anything related to updating my database, I'm going to put in this command service, right? All my write operations are going to go through here, and all my read operations are going to go through the query service. So I'm separating out my logic, and any writes are going to go to this. They often will use them at sourcing, and they're going to store just raw edits in here. And they'll read from a read replica, or maybe even a separate database entirely that was created just with the current views, the current like rehydrated values of each thing. And these values might not be completely consistent, but eventually they're going to be consistent. So we call this eventual consistency. So CQRS is really interesting to try to get around some of our performance concerns that we might have. One of the things that CQRS tries to avoid is caching, because you can have a lot of bugs come out through caching. Because if we cache a value and then we update the database and we don't update the cache, well, now we've got some invalid data stored, and that can cause all sorts of problems. So CQRS is something I would definitely recommend you reading about, as is event sourcing. Another really interesting thing is this domain-driven design concept, which has been around for 20 years, but it's becoming more and more relevant as we talk more about microservices. I don't have time to get full into domain-driven design, but one aspect of it is that we take our business domain, our data objects, and we say, hey, I'm going to identify some related things. So I've got some entities over here. I got a customer entity, an order entity, an invoice entity. Well, these are kind of related to each other. So this might be what we call a bounded context of like related entities. And we got this one root thing here, customers, right? So everything here is in the customer context. Then we've got like a products and models and additions. This is all in a separate context, right? And so now I can separate my code out. So I got some code that deals with products and some code that deals with customers. And it helps you organize your applications a little bit better. But it doesn't just end there, because if we have two different contexts, why can't we store them in two different databases, right? Why can't I have a customer database and a products database? There's a bit of a horizontal partitioning for your database going on here. And if customers might make sense as a graph database and products might make sense as a document database, there's no rule that says they have to be the same database technology, right? So we start to be able to have a little bit more freedom at the database layer and have different things in different database technologies. And you might look at this and say, well, wait a minute, if I've got separate logic here for customers and separate logic here for products, well, can't I just split those off too? And so I have one service related to customers and one service related to products. And that's exactly kind of what we do. And what we do here when we do this is we say, hey, I've got a microservice. This is a little service related to a small thing. It's got its own data. It owns everything about that. This other thing owns everything about customers. And you put all these things together and you get this new buzzword called microservices. And microservices they exist to solve the problems that we have in very, very, very large monolithic applications that too many people are trying to work on, and they're all stepping on each other's feet. It becomes harder and harder to organize your code in larger organizations. So you can break up a monolith into these little microservices that all have their own little pieces of data. Monoliths on their own aren't bad, but once you reach a certain scale, it becomes hard to maintain them at an organizational level. And you start to say, well, what if we could have a team that's just working on logging or billing or authentication or whatever, right? And that's sort of this idea of microservices. But microservices have penalties. it becomes much harder to think about your application and all the various pieces of it, because you're now thinking about how is everything communicating with each other. And you might not be working on all these aspects. It might be a separate team. You might only talk to the teams that your service has to interact with, right? So it becomes very hard to understand the whole organization when you're in a microservices type world. So that's one of the drawbacks. Another drawback is you need to think about things not working, right? It's when you have more and more moving parts, the likelihood of some network issue breaking communication becomes higher. The likelihood of some machine going down or experiencing planned maintenance, it grows. And even updating all these things and organizing releases sometimes becomes a challenge. So these are all problems that we have solutions for. There are wonderful technology solutions for this. Debugging this becomes harder, but we have solutions for that in logging, and log streaming and log aggregation. There are solutions to all these problems. But does your organization who's just trying to get its first 100 users need to worry about things at this scale? Probably not is my answer to that. By the way, I have these defined as communicating directly with themselves. They don't necessarily make direct calls to each other. There's event-driven architectures that will fire events, and then other services will just listen for those events. And those are a little bit more scalable, but I don't have slides for that yet. So apologies there, but just so you know, they're not always making direct calls out to each other. So finally, let's conclude. Reddit is now the world's leading organization. They have 7 billion active humans every day somehow. But for you and your applications, I want to give you a few warnings, right? First warning, if you're playing with this stuff on the side, it can be really expensive. I have seen some things related to cloud hosting. So if you are trying to run play with scalability and servers and things like that on the cloud, be really, really careful. All of them have ways to check your cost and get alerts when you start exceeding your budgets. So look for those features first and foremost. Last fall, I had a student experimenting with databases in the cloud, and they accidentally chose a different database tier than they meant to, and they wound up getting a $300 bill at the end of the month from Azure. Now, thankfully, Microsoft is awesome, and he talked to them, and they actually waived the fee. I didn't think they would. And he now goes off and he works with Azure professionally, which is pretty cool. But you need to be careful because you might not have that level of luck. There's a lot of jokes going on about people who leave virtual machines running on Azure or AWS and things like that. And it's not a credit card bill you want to see. But I want to you to keep in mind that not all of these things do the same thing. All these things might serve up the same application, but they're going to handle a different scale. They're going to handle a different team size differently, right? Unless you're Netflix, you probably don't need large microservices with horizontal and vertical scalability at every layer, right? You might be just fine to run on a simple little client server database, right? That's what I'm running right now on my own side projects. Works just fine for me. If it ever takes off, yeah, I might scale up to something like this or go NoSQL or something like that. But go with what you need right now. So my advice, just sort of timeline perspective, if you're a startup in your early stage, you're probably the first, as soon as you start having server issues, you're going to want to scale up your server vertically to restore service. And then you're going to want to start looking at what's actually going wrong and planning a little bit more. You should be minifying and bundling if you're doing a lot of JavaScript. Once you start having issues, you're going to want to be optimizing your queries and finding ways to work with your database to monitor those queries on a regular basis. It varies by your database vendor how that works. Once you really start taking off, you're going to want to make sure you have rate limiting. You're going to want to add that load balancer for horizontal scalability. In Azure, for example, that's really simple. You just say, hey, I want to scale out to 3 servers. And Azure says, great, I'll charge you more. And you say, fine. But you want to probably get into horizontal scalability there. You're probably going to want to add some sort of a cache, and you're going to want to plan ahead for what's next, specifically for the database. Figure out your strategy. Are you going to be using something like domain-driven design and these little small databases? You're going to be looking at NoSQL. Are you going to be looking at database partitioning? There's all sorts of right answers to these questions, right? It's going to be based on your team's experience and your problem domain and your particular needs and timelines. And finally, where you're getting really big, you need to take care of that database. You need to have probably go to microservices. You need to have some serious automation going on in terms of deployment, in terms of debugging, and you need some serious maturity at the logging level as well. So these are sort of my recommendations for the various stages an organization might be. The one caveat to this is if you're already a giant organization and you're launching a new product, you expect to have a lot of usage, skip the early stages. You need to be somewhere over here, maybe even over here, right? I know this is a lightning kind of a tour of scalability. Some books I would recommend that you look at if you're curious about these things. First one would be O'Reilly's Fundamentals of Software Architecture. It's a really good way of looking at various patterns. I really like this read. This is really good. Actually, everything in this O'Reilly architecture series is very good, but it tends to be more on the advanced side. It's not necessarily bad. It's just this talk is more of an introduction. Another book that I am reading bits of, but I have not finished it, is Web Scalability for Startup Engineers by McGraw-Hill. I really like this. It sort of takes you through all the different stages of an application, all the different parts, and it looks at some of the same scalability concerns. Very good book from everything I've seen. And finally, the reason why I'm actually giving this talk is to force myself to generate material and diagrams, etc., for a book that I'm working on just for releasing self-published in the fall, called New Developer's Guide to Application Scalability. So really the concepts from this talk and then the stuff I couldn't fit in for time and just more details, more ways to get started, etc. You can check that out at newdevsguide.com. I would really appreciate it if you put in your email address and say, hey, notify me. It helps motivate me a little bit to say, like, okay, people are interested in this. This is something I should be investing my time in. I'm about 65% of the way through my first draft right now. I'm looking to publish in the fall. Finally, I love my employer. Tech Elevator is awesome. If you are looking to hire, if you're looking to get involved in the technology community, if you are looking to get into tech or your family is, talk to us, right? This is my boss, Vinny Sanfilippo. He's awesome. He's wonderful. And there's his email, just vinny@techelevator.com. But I started working here because I love the quality of students that I saw coming out of the program, and it's been the most fulfilling job of my career. It's really wonderful to be able to invest in people like this. And finally, here's my contact info, but who has the first question?
Thanks, Matt. Thank you for going over the lightning tour of application architecture and scalability. So if you have questions, feel free to ask Matt, and you can always reach out to Matt on Twitter if you have subsequent questions. Feel free to ask your questions, and we would like to thank Improving Today for supporting our online meetups. So thanks to Improving.
And Bhaskar, thank you very much for having me. I really appreciate the chance to teach a little bit more of the community.
Yep. So Matt, a small question. So you were discussing about in your slides, you showed about you can split like you can have database copy the same, like each service will call its own database server.
Sure.
Right. So when there is a distributed application, do you think a replication would help if there are individual database instances?
Tell me a little bit more about the scenario. What do you mean by distributed? Like how distributed are we talking here?
So we in your slide, like you had like web application services, you had like 3 application services and each pointing to its own copy of database server. So
sure.
and you mentioned that we should not be doing this because we don't know which particular database our request would have went. But do you think in that case, if there was a replication like a chain between database 1 to database 2 and database 3 and backward, so
sure.
that anywhere there are updates, it might go into the corresponding instances. Is it a right thing to do, or
Yeah,
not to do?
you could do that if you could look at the replica. If you don't want to write data, you could look at the replica if you don't care about the full accuracy of the data. Sometimes we need the exact accuracy, right? Like if we're starting an edit, we need to be pretty close to accurate.
Correct.
But in many cases, you can offload a lot of the normal stuff to data that's pretty close to right.
So we have, I think, in the chat, in Zoom chat, you mentioned that as you scale, you might want to switch from relational DB to NoSQL DB. Is there a case where relational DB is better? We are currently using document-based NoSQL DB and are having issues with its querying limitations.
Yeah, and that's where databases are awesome. Like relational databases are awesome because they're built for that sort of enforcing a schema, like making sure the data is accurate and correct when it comes in, and they're built for querying as well. Sean, you may have better luck with something like Couchbase. I know Couchbase is built a little bit more for querying than something like Mongo, and it's still a document DB. If you're interested, hit me up on Twitter. I'll be able to help you talk to a local guy I know who does a lot with Couchbase, but I am very much not a database administrator or database professional. It's my weakest area technically. So I'm still very much a journeyman there. But that is a weak area for many of these NoSQL database providers, is they're not as good at querying. They are fast, they're flexible, but it's sort of like turning the safeties off and just going as fast as you can in some cases. And that's not always a good thing. Different pains for different databases, I guess.
Yep. So if there are no further questions, I think you can always reach out to Matt on Twitter, and you can ask follow-up questions with Matt. Matt is very active in Twitter community. So thank you for speaking, Matt, and thank you all for joining today's Meetup talk. Hope you had some information about application architecture and scalability from Matt today. Feel free to share your feedbacks to Matt, like whatever is, if you found whether it was good or if you think that there can be some additional information. So anytime, feel free to share your feedbacks with Matt. Absolutely. Thank you all. Yep. Thank you all. Thanks for joining today.